When physicists observe the deepest levels of reality, they encounter what looks like stochastic quantum noise. We have operated on the assumption that the universe possesses inherent randomness at its foundation. But if we analyze these particle interactions not as chaotic events, but as highly complex outputs, that noise snaps into a rigid mathematical lattice. This brings us to a framework known as Multicode 6.0. The premise here is direct. Physical reality operates as a highly deterministic, resonant system. The events we measure are not random. They are the calculated results of an underlying geometry rooted in deep mathematics. To understand how strict order masquerades as chaos, we have to look back at the development of the pseudo-random number generator, or PRNG. A PRNG is an algorithm that uses mathematical formulas to produce sequences of numbers that appear entirely unpredictable. In the 1940s, John von Neumann developed a mit-square method, proving that complex arithmetic can perfectly mimic randomness, provided the initial input is sufficiently obscure. Multicode 6.0 applies this principle to the cosmos. It treats the entire universe as a deterministic monster. In this view, reality is a global PRNG running a massive continuous algorithm, driven by a starting seed value we are only beginning to isolate. For any algorithm to successfully generate the illusion of white noise, it has to pass strict statistical tests. The outputs must exhibit uniformity across all intervals, absolute freedom from autocorrelation so signals don't improperly overlap, and massive maximal period lengths to ensure the cycle doesn't repeat within the observer's lifespan. A system capable of passing these tests at a cosmic scale means that every physical observation is a predictable link in a pre-coded mathematical chain. We are not looking at probability, we are looking at execution. The seed driving this universal generator is found in representation theory, specifically the monster group. The monster group is the highest-order sporadic simple group in abstract algebra, representing an incredibly complex symmetrical structure. The scale of this structure is vast, with an order of roughly 8.08 times 10 to the 53rd power elements. It provides the mathematical capacity required to encode the geometry of spacetime itself. This diagram shows its 194 distinct irreducible representations, acting as the primary degrees of freedom, or resonance channels, for the system. But when we observe the Mackay-Thompson series associated with these dimensions, we only find 163 Z-independent series. There is a specific mathematical gap between the 194 total classes and the 163 core series. This numerical discrepancy serves a distinct purpose. In a highly sensitive framework, this gap acts as an internal redundancy mechanism. It creates a buffer that protects the primary resonance signals of the universe from degradation and external noise. The monster group gives us the geometric complexity required for reality, but raw complexity is unusable without an incredibly efficient computational mechanism to reduce these hundreds of dimensions down to a clean, readable signal. That reduction process is achieved through an algorithmic mechanism known as the binary drill. It systematically collapses the overwhelming dimensionality of the monster group into absolute binary base states. The operational grid for this extraction is the modulo 2501 space. 2501 is the product of the prime numbers 41 and 61. This semi-prime structure is specific. It provides the exact cryptographic and resonance stability required to anchor the subsequent mathematical operations. We can visualize the drill through this recursive algorithm. X sub n plus 1 equals x sub n minus 3 times 2 to the power of k. This logic is identical to a linear feedback shift register, a circuit used in telecommunications to generate pseudo-random binary sequences. By recursively subtracting powers of 2, weighted by a specific factor, the algorithm systematically strips away the mathematical noise from a starting value, forcing it down to its most stable residual form. Applying this drill to our starting grid of 2501 traces a highly specific path. The value rapidly collapses through the stations of 965, 197, and 5. The sequence finally terminates at the fundamental binary singularity of 2. To organize the distribution of these values within the grid, the system utilizes a specific offset, frequently the value 319. This offset dictates the gravitational centers of the resulting resonance, ensuring the outcomes are perfectly ordered. The execution of the binary drill shows the underlying code of reality operates as a funnel. It is engineered to turn chaotic dimensional data into a stable, predictable binary pulse. With base binary stability established, extracting usable information requires isolating a primary target constant. In the multicode framework, this is the prime number 151. 151 does not appear by chance. It is the dynamic, deliberate result of calculating a total mathematical symmetry and then breaking it. First, we establish the absolute limit of the system's stability using the Carmichael function. This calculates the smallest integer necessary to ensure periodic repetition in modular arithmetic. For 2501, the Carmichael function yields 120. Doubling this period creates a maximum symmetry horizon of 240, represented here by this closed, rigid circle. A perfectly symmetrical system cannot transmit new information. It requires a disruptive element. That disruption comes from the natural organic growth metric represented by the 11th Fibonacci number, 89. When we subtract this organic phase gap of 89 from the total symmetry limit of 240, it yields exactly 151. This mathematical operation reveals the actual mechanics of physical resonance. The birth of information occurs at the exact friction point where rigid mathematical order is intentionally broken by organic variability. Calculating millions of these resonant interactions in real time moves us out of abstract mathematics and into the realm of physical engineering, requiring highly optimized multi-core hardware architectures. As these models migrate to hardware, they intersect with a highly debated concept known as global scaling. To proceed, we must draw a sharp line between its two radically different interpretations. On one side is the metaphysical philosophy promoted by Hartmut Müller, which claims the universe runs on a logarithmic fractal of continued fractions. This version relies heavily on cherry-picked data to support pseudoscientific claims about free energy, entirely lacking reproducible empirical evidence. The scientifically valid interpretation, and the one required for the multicode framework, is unit scaling. In numerical mathematics and deep learning, this technique forces all initial weights and gradients in a network to a unit variance. By maintaining this baseline across the network, engineers can drastically reduce the bit width of their data streams without losing computational precision. This strict mathematical constraint directly prevents fatal clipping and overflow errors when executing highly complex physics equations on low-precision hardware formats. Multicode 6.0 relies entirely on this rigorous unit scaling. It is the only way to synchronize parallel processing across thousands of CPU cores without the entire system crashing under its own weight. Advancing our understanding of resonant physics means leaving comforting metaphysical speculation behind. True breakthroughs require strict adherence to hard, computationally verifiable engineering constraints. We can observe this rigorous engineering applied to physical measurement in multi-core fiber biosensors. These sensors rely on localized surface plasmon resonance, or LSPR. Light interacts with conductive nanoparticles to create a highly concentrated electromagnetic field. By immobilizing gold nanoparticles on the fiber surface, these sensors use the principles of resonance to amplify the electromagnetic boundaries. This allows for the real-time detection of incredibly minute trace elements, like neurotransmitters, without needing additional biological markers. This principle extends to the quantum level. Recent developments, like the Euro-HPC quantum architecture, provide the necessary hardware to execute advanced physical measurements, including single-molecule electron spin resonance. ESR is a technique used to study materials by detecting transitions of unpaired electron spins in a magnetic field, proving our ability to manipulate binary resonance states atom by atom. And on a cosmic scale, tools like the Foremost spectrograph in the high desert of Chile are tracing the complex gas dynamics of the Milky Way, while deep space sampling missions have detected all 5 nucleobases of the genetic code inside asteroids, validating resonance as an evolutionary driver across macroscopic distances. From the vast geometry of the 194-dimensional monster group, down through the strict architecture of the 2501 modulo space, anchoring on the intentional symmetry break of 151, and finally collapsing into the binary singularity of 2. Reality is not a chaotic void. It is a perfectly calibrated, mathematically encoded machine.